Okay. Now we come to the very final law, and that is the general gas equation. The general gas equation. General gas equation. Now, in the general gas equation, remember one thing, nothing will be kept constant. We will not say pressure is constant. We will not say temperature is kept constant. We will not say volume is kept. These are the three constants. Temperature not kept constant, volume is not kept constant, pressure not kept constant. And when you don't find all these three mentioned there, then you know fully well you have to attempt or use the general gas equation. How will we derive it? The general gas equation is derived from Boyle's law and Charles' law. First of all, tell me, what is Boyle's law? Just give me the equation, the original equation, first equation.
V1 into V1 is
No, bearing, the word bearings. Bearing, give me the law. Take the law. Don't give me the formula. Give me the law. Boyle's law, what? What is Boyle's law?
Pressure is inversely proportional with the volume.
Okay, pressure varies inversely as volume. We can say also the same. Volume varies inversely as pressure. Correct?
Temperature is kept.
That is okay. Temperature, that's okay. Temperature, all right. You say temperature kept constant. Now, what is Charles' law? Charles' law. What is Charles' law? What is Charles' law? Yes, Ian. What is Charles' law? Here we've got volume varies inversely as pressure. Charles' law.
Charles' law is that the temperature is constant. No, the pressure is constant.
But I want the equation. This equation. Not the final. I want this equation. I want the law. Here volume varies inversely as pressure. There Charles' law is what?
V1 by.
You're giving me the derivation. I'm asking you the law. Here the law says that the volume varies inversely as pressure. What does the law, what does Charles' law state? Do you know? You that boy at the back? You?
V is proportional to.
Proportional?
V.
V
Comes sine and then absolute.
varies.
Varies. Absolute temperature.
Directly. Varies directly as absolute temperature. Here V varies inversely as pressure. Here V varies directly as temperature. Correct? Absolute temperature, what is temperature? Correct? All of you got that now? Now get the final derivation. If V varies inversely as pressure and V varies as temperature, can we combine both of them and make it one equation? How will we combine both of them and make it one equation? Ian, how will we combine both of them and make one equation? This is equation 1.
V into V.
This is equation 2. So V
Into V.
into what?
V. V.
V into V. Why V into V?
When those two are there and you're putting them together.
You're putting them together. Yeah, so then V varies as inversely as pressure and V varies as temperature. So put them to combining together, what will you get?
V into V.
V varies temperature upon pressure.
Yeah, temperature upon pressure. V varies as 1 upon P and V varies the temperature. So temperature upon P, correct. Follow? Therefore, you have got now V is equal to T, P, K. K is a constant. Oh, don't bother about this. We just write down there. Let us make it more simple here. This much you have all understood, no? Correct? Now what we have is now PV upon T is equal to K. P equal to PV upon T is equal to K. Correct? Understood all of you this? Yeah? Therefore, what is your gas equation? General gas equation is P1 V1 upon T1 is equal to P2 V2 upon T2 is equal to P3 V3 upon T3 is equal to K. Understood? So remember one thing. Boyle's law is P1 V1. Sorry. What is Boyle's law? P1 V1 no, sorry, P1 V1 is equal to P2 V2. Correct? That is Boyle's law. What is Charles' law? This is Boyle's law. This is Boyle's law. Boyle's law. What is Charles' law? Charles' law is what now? Here. P1 V1, sorry. V1 upon T1 is equal to V2 upon T2. This is your Charles law. And your general gas equation is P1 V1 upon T1 is equal to P2 V2 upon T2. You have to ask, you will be asked to derive Charles' law. You will derive Charles' law. You will be asked to derive Boyle's law. Derive means get this final statement. How will you derive? From here, how will you come here? That's called derivation. From here, how will you come here? Derivation. Then from here, from these two, how you get this? That's called derivation. Okay? That's called deriving the various laws. Have all of you followed this? Yes or no? Now read and work out the problems. Read and work out the problems. And I finish up the chapter because I finished up the chapter. If graphs are not there in your course. Is this here? Keep your head up straight. If you want to sleep, pack up your bag and go home. Don't sleep in my classroom. Come on, start reading and working out. You are playing the food. Pack up your book and go home. I told him that I'm getting fed up correcting you children. Do you want me to work out one problem on the board on general gas equation? Okay, I'll do it. What?
Now you can solve it.
Huh?
You can solve it.
Okay, another thing, one more thing is to be remembered here. And that is, please pay attention here. There's something called aqueous tension. Aqueous means what? What is the meaning of aqueous? Water. Now, from where the water comes, some of the gases are collected underwater. Hydrogen, nitrogen, okay, those oxygen, those that are lighter than air and insoluble in water are collected by the downward displacement of water and the upward delivery of the gas. Now, even though they are not soluble in water, they come out moist. The gas has come out moist because it has come through water. That gas, when it exerts pressure, that pressure that is exerted by the gas is the gas pressure plus the water pressure. That water pressure is called aqueous tension. So you have got the total gas pressure, total gas pressure, that is called pressure total. Pressure total is equal to the pressure of the gas plus pressure of the water vapor plus water vapor pressure. Okay, pressure of the gas plus pressure of water vapor. So if they ask you what is the, give us the pressure of only the gas. So therefore, pressure of gas only is equal to total pressure. Pressure total minus pressure water vapor. When you take out the pressure water vapor from the total value, you will get the individual. Or if you want water vapor, then total minus gas. That you know. Follow? That is the meaning of aqueous pressure. That means pressure that is exerted by water. From where did the water come? The water came from from the process that we use when we collect the water, when we collect the gas, when it is being prepared. It is prepared by passing the gas through water. Downward displacement of water, upward delivery of the gas. That water doesn't sometimes sticks to the gas and makes the gas moist. The gas is not dissolving in the water, but the water has got stuck on the gas. Just as you say, when you have a bath, you don't get dissolved in the water, but you have a lot of water stuck on your body. So when you come out of the bathroom, your weight will be much more until you are dried up. Correct? That is called aqueous tension. Okay? Now we will start here. here. Pressure for gas at STP is doubled and the temperature is raised to 546 K. What is the final volume of the gas? Now, what do you think? Which law will be used here? That last point. Which law will be used here? Which law? Will we use Boyle's law? Why not?
Because
Why are you opening your mouth? Will we use Boyle's law? Why not?
the pressure is not constant.
Okay, then what law will we use? Will we use Charles' law? Will we use Charles' law? Why not? Loudly, I can't hear.
Pressure is not constant.
So what law will we use then? What law will we use? Do you know? You? What law?
Yeah, it's a general law.
What is general gas law? What is it?
V is mostly proportional to
You give me the final statement. Now you don't give me the law. You give me the calculation, that equation I want. You give me the final equation.
P1 V1 upon T1 is
V1 upon
P1 P2 upon
T2. Correct? Is this clear? Now here. Pressure for gas P1, V1, P2, V2. Okay? Now what is P1? Pressure for gas at STP. What is STP here? P1 V1 upon T1, sorry, is equal to P2 V2 upon T2. What is the STP here?
standard atmosphere.
What is it? Give me the figure.
76.
You have to use, you use temperature, what I said, pressure, no? Pressure for gas at STP is double the data. So what is it? It is 760. STP says 760. Now the pressure for gas at STP is doubled. Double means what? 760 multiplied by 2. Correct? Yes or no? Okay. And the temperature is raised to 546. So first temperature is what now? 273. Final temperature will be 546. Yes or no? Then, what is the final volume of the gas? So final volume of the gas is here. What is the initial volume?
Not given. Not. And it will be in terms of like how much times of the body.
And now you collapse. Now you find out the value. Now find out the value.
P2 is 1 5.
Okay.
How is P1 1?
That is taken. That's taken as one. Okay. All right.
Not P2 is 1520.
Pardon me.
P2 is 1520.
What is it?
P2 is 1520.
15. P2. 15 by 115. This is K, no?
P2.
P2. When you multiply this two. That you can do on your own. So what you have got now? P1. P1 is 760. 760 multiplied by V1. 1. P1 V1 upon T1. T1 is 273 is equal to P2. P2 is 760 multiplied by 2 multiplied by V2, which is X, upon 546. Correct? Yes or no? Now what we do is find out the value of X. Therefore, X is equal to what then? X is equal to what? 760
520.
into 546. 546 upon 273 multiplied by 760 multiplied by 2. Am I right or wrong? Now you cut out immediately. 760 will cut out, 760 will cut out here.
273 will cut out.
273 will cut out here, 273, that is 2. 2 and 2 will cut out. Therefore, your x is equal to 1. So your volume is 1, V1 is also 1, and your V2 is also 1. Followed? It is clear, all of you? Okay. I'll work it out. Work out your sums. How many sums that boy? Bring me a book. How many sums have you worked out? That boy? Ian, how many sums have you worked out? Let me see. How many sums? Let me see how many sums have you worked out. Come here, let me see your work. Bring me your book here. Huh? Give me a book here. Get this signed by your mother. Come here. Bring the book here. Bring the book here. Bring the book here.
What about the fourth question?
Which fourth question?
Oh, that's good.
Huh?
That fourth question.
I
Wait.
this is what V6, no? Yeah, okay. Get this signed by your mother. Go take your book.
No, we don't have this one. No, not the Can you learn the Excel? Not right now. Wait some time. You just stand up and it's very short.
Are you all getting your sums? Those who are attempting, are you getting the sums or not getting them?
We're not even. We just rate activity everything.
No, but previous ones, what about Charles Law? You didn't do sums from Charles Law? You didn't get the sums or you didn't get them? Hmm. Are you getting the sums? Come here, come here. If you don't get the sum, come here.
-14 mm from
A gas is collected over water at 17 degrees Celsius. If the volume of the gas collected is 500, that is the volume, the dry gas at 17, the vapor pressure is -14. Huh? So you have to -14 mm from this STP, no? So from 760,
750. I thought it's
750, no, why 750?
But it's pressure, total pressure.
What we, yes, yes, yes.
You said it's
Bye. It's getting cool now. This is enough.
You don't tell me the second muscle.
Huh?
Instead, that this.
No. Then turn this one off. No. Bro, shut up.
Okay, at least turn on this one.
No, it's okay. Man, I don't know. It is the 20th.
Now, what is Kelvin zero? Like 0 Kelvin, right?
-270.
You cannot reach that. You cannot reach that scale. Zero scale is -273 centigrade. You cannot reach that. Yeah. It's difficult to reach that temperature.
Minus 273. Deep freezing. Deep freezing.
And then that is when you
Are you getting the sums, boy? Subsequent, give me a book. Let me see how much work you've done. That's all. All the sums are contained in those 3.5 pages. You have got to work out some from Selena and also from Dalal.
We don't have the.
You can borrow the book, no? Have you finished from Dalal? Have you finished from Selena?
Yeah.
All the problems from Selena? All the problems from Selena you finished? Back in text also and outside back also?
Mark, there are like not much. But
Back there are not much?
no. Wait. Yeah, here this is from this to this, from inside. This is the back.
Only that much? Are the problems?
How do we find P1? How do we find P1? Pressure will be constant. That's what they
The temperature to find out. Temperature, no? So the temperature I'm given to you, then take the normal temperature, STP, that is 273. Take it as 273. Don't talk, do your work. You have to concentrate when you're working.
Definitely not in my I went once. Twice. Then friends. Why did your friends in your bedroom?
You're already in. Yeah.
You're still in though. No. To go like this. No. Yeah. So basically, there is a main challenge which to be blasted. So basically, we learn about there is
So now you post some assume drifting on ये फिर भी डाउट आ रहा है that book which you marked was of the last Jolly ma'am said that no.
Bye guys, bye guys.
This thing, your, this is maximum.
Pallu.
नहीं वो तू थी नहीं ना, तुम अकेले कैसे बैठे?
तुम तेरे को बैठ जाने का, मैं आती हूँ, मैं लेट आऊंगी बट मैं आऊंगी, और अगर नहीं आऊंगी तो इसको मैसेज करूंगी।
हाँ देखो हम लोग के साथ बैठ जाना।
हाँ।
इट्स अ कौन चलता है? बंद कर दो पहले।